in the previous video of solution of numerical methods, so that is the solution of nonlinear equations, we have seen bracketing methods. Now we will see open-end methods. So open-end methods for the solution of nonlinear equations. Solution of nonlinear equations. So those include secant method, Newton-Raphson method, and fixed point iteration method. So here the open methods are sometimes called as extrapolation methods. Now for the first method, that is secant method. This secant method is the modification of Regla-Folsey method, which we have seen earlier. So that is the modification of Regla-Folsey method. And here it is not necessary that the test interval must contain the root. Therefore they are called as open methods. So with the help of IMET we are taking one interval, that is AB, that will be based on intermediate mean value theorem. So according to the intermediate value there is a root between this interval. So but the second method, these are the open methods, therefore the root may not be in the test interval. Now if suppose x1 and x2 are any 2 points between the test interval AB, where a and b are consecutive integers such that f of a into f of b is less than 0, which is based on IMVT. Now if suppose x1 and x2 are any points in AB, then the first approximation is given by x3 is equal to x1 f of x2 minus x2 f of x1 minus f of x2 minus f of x1. Here with the help of x1 x2 we are getting x3. Now for x4 this will be what we are using x2 and x3. This is x2 into f of x3 minus x3 into f of x2 divided by f of x3 minus f of x2. So here we call this as modification of Regla-Folsey method because the formula is same, but we are neglecting the condition that we have to apply IMVT at each step. IMVT at each step for Regla-Folsey method, but it is not the same here. Here just we are using the previous iteration values for the next iteration. So this is about secant method. Therefore the general formula which involves xn and xn minus 1 for if it involves xn and xn minus 1 iteration, then the n plus 1 iteration will be xn plus 1 is equal to xn minus 1 into f of xn minus xn into f of xn minus 1 divided by f of xn minus f of xn minus. So this is how we use the general formula for finding the iteration value with the help of secant method. This has to be remembered. This is very important. Here n is greater than or is equal to 2. So if you put n is equal to 2, that will be first iteration, that is given by x3. So now here also we will stop at that iteration where the consecutive roots are very close. Suppose error bound is mentioned, the difference between the two consecutive roots, suppose it is xn minus 1 and this is xn, the difference is very small, which is s is equal to error bound, then we have to stop at that step. So nth step we have to stop. Now the order of convergence of the secant method. The order of convergence of secant method is nothing but the positive root of the quadratic equation x square minus x minus 1. The positive root of x square minus x minus 1 is equal to 0. The roots are x is equal to minus b means 1 plus or minus root of b square is 1 minus 4 into minus 1 divided by 2 into a means 2 into 1. This will be 1 plus or minus root 5 by 2. So positive root implies 1 plus root 5 by 2. Therefore the order of convergence of secant method is 1 plus root 5 by 2. This is nearly is equal to 1.618, or sometimes we can write it as 1.62. You can observe this number is greater than 1 but less than 2. Therefore this convergence is called superlinear convergence. Convergence is called superlinear convergence. Now we will see Newton-Raphson method. So the next method is Newton-Raphson method. Sometimes it is called Newton's method, which is based on tangent line, which is based on tangent at a point to the given function. F of x is equal to 0 is the given problem. Here we have to draw the tangent. It is based on the tangent line. So that gives approximations. So general formula for Newton-Raphson method is given by xn plus 1 is equal to xn minus f of xn by f dash of xn, such that n is greater than or is equal to 0. Here it should be remembered that f dash of xn is not equal to 0 because it will be infinity. Therefore we have to choose the point such that f dash of xn is not equal to 0. Here also we have to have the test interval which is based on IMET. Even though it is a open-end method, it doesn't involve the root. Still we have to take one test interval so that the initial guess x0 will be easy. So for initial guess x0, that is x0 belongs to the closed interval AB, then the first iteration is given by x1 is equal to x0 minus f of x0 divided by f dash of x0. Here in order to take the initial guess we need the test interval, therefore we are taking the test interval, whether the method is either open end or bracketing method. It should be remembered, irrespective of which type of method it is, we have to take the test interval which is based on intermediate mean value theorem. Now the order of convergence. The order of convergence of Newton-Raphson method is 2. So because the error in the n plus 1th iteration to the error in the n plus 2 to the power 2 is a constant. So therefore the order of convergence is the power of n. So that will be 2, which is called as quadratic convergence. Therefore we have to remember Newton-Raphson method converges quadratically because the order of convergence is 2. Now we see one more method, that is called fixed point iteration method. Sometimes it is called successive approximation method, or method of iteration, or sometimes simply called as method of iteration. Here also the problem is given in terms of f of x is equal to 0. Again we have to find the test interval AB, which is based on intermediate mean value theorem. Here a and b are consecutive integers such that f of a into f of b is less than 0. Now this given f of x should be rewritten as x is equal to g of x, such that modulus of g dash of x should be less than 1 within this interval AB. So in that case, the general form of the iteration formula for fixed point method is given by xn plus 1 is equal to g of xn. Here n is equal to 0, 1, 2, 3. For first iteration, n is equal to 0. This will be x1 is equal to g of x0. Here x0 is taken from the interval, the closed interval AB in the test interval. So here, irrespective of the method, whether it is open end or closed, open end or bracketing method, we have to use the intermediate value theorem, so that the we are very prone to take the initial guesses. So it is very easy to take initial guesses from the test interval. Now this is all about the open end methods. So we have seen 3 open end methods. Now we have forgot the order of convergence of fixed point method. Order of convergence of fixed point method is, or fixed point iteration method is 1. So therefore it is called linear convergence. So this is about the open end methods. Now we will see some questions on these open end methods which has been asked in the previous competitive exams. The first question is, it's a question of KSET 2018, which says an iterative formula by Newton-Raphson method to compute the reciprocal of a natural number n is. We have some options. Xn plus 1 is equal to xn into bracket 2 minus n xn. Second option, xn plus 1 is equal to xn into bracket 1 minus n xn. Third option is xn plus 1 is equal to xn square into bracket xn minus n. And fourth option says xn plus 1 is equal to xn into bracket 2 plus n xn. Now we will see. So computing reciprocal of a natural number. So reciprocal of a natural number means 1 by n is equal to x. The formula is given by f of x is equal to 0 can be written as, in this case, 1 by x minus n is equal to 0. Now here it is Newton-Raphson method. The general formula for Newton-Raphson method is given by xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Here we can compare these two equations. Therefore f of x is equal to 1 by x minus n. Therefore f dash is equal to minus 1 by x square. Just putting this, xn minus f of xn will be 1 by xn minus n divided by minus 1 by xn square. So this will be equal to xn plus 1 minus n xn into xn. So we can rewrite it as 2xn minus n xn square. We can take xn common, xn 2 minus n xn. Xn plus 1 is equal to xn into bracket 2 minus n xn. So it is observed in option 1. Therefore the correct option is option 1. Xn plus 1 is equal to xn into bracket 2 minus n xn. Now another question from KSET 2020. It says the sufficient condition for the convergence of Newton-Raphson convergence scheme. It is given by xn plus 1 is equal to xn minus f of xn by f dash of xn is. You have some 4 options which are in terms of modulus of some f and f dash values. The option 1 says modulus of f of xn into f dash of xn is less than modulus of f double dash of xn whole xn. Second option says it is the modulus of ratio of f of xn into f dash of xn divided by f double dash of xn to the square is greater than 1. The third one is less than 1. And the fourth option says modulus of f of xn into f double dash of xn divided by f dash of xn square is less than 1. Now we will see what will be the sufficient condition. We have the iteration scheme that is given by xn is equal to xn minus f of xn divided by f dash of xn. So it looks like x is equal to g of x. Then for the convergence of this fixed point iteration method, we have modulus of g dash of x is less than 1. So therefore we have to take this as g of xn, that is xn minus f of xn divided by f dash of xn. We have to differentiate g of xn with respect to xn. Therefore g dash of xn is, this is 1 minus u by v formula. So f dash as it is, this is differentiation f is f dash minus f as it is, differentiation f dash is f double dash xn divided by f dash of xn to the power 2. So for convergence, modulus of g dash of xn should be less than 1. So we have to take less than 1 for this quantity. So that is 1 minus f dash of xn, this is 2 times, minus it will be plus f of xn, you can rewrite it as, it is modulus of, can just multiply, cross multiply, f dash of xn to the power 2 minus f dash of xn to the power 2 plus f of xn multiplied by f double dash of xn divided by f dash of xn to the power 2. This is less than 1. So this implies modulus of f of xn into f double dash of xn divided by f dash of xn to the power 2. This is less than 1. So just we can compare this with the given options. F of xn into f double dash of xn divided by f dash of xn to the power 2, the modulus is less than 1. So this is seen in option 4. Therefore the correct option is option 4. The same question as once asked in GATE exam, one of the GATE exam. So this is about the sufficient condition for convergence of Newton-Raphson scheme. Now next question. It is a question of GFGC which has been asked for assistant professor in 2015. The question says, the iterative procedure for evaluating cube root of 2 by using Newton-Raphson method is. We have some 4 options. We will see what is the iteration procedure for evaluating cube root of 2. So we have here the f of x, we have to have problem f of x is equal to 0. Here f of x means evaluating cube root of 2, that is x is equal to cube root of 2. So which can be written as x cube is equal to 2, that is x cube minus 2 is equal to 0. Therefore f of x will be x cube minus 2. Now for the Newton-Raphson method we have to have f dash. Now f dash is equal to 3x square. Now just putting in the iteration scheme, that is given by xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So here xn is xn only, f of xn is xn cube minus 2, f dash is 3xn square. So this is equal to, so just cross multiply and simplify, that is xn cube 2xn cube plus 2 divided by 3xn square. Just take 2 common from above and 3 below. This is xn plus 1 by xn square. This is 2 by 3 xn plus 2 by plus 1 by xn square. So this is observed in, therefore xn plus 1 is equal to 2 by 3 into bracket xn plus 1 by xn square. That is observed in option 3. Therefore the correct option is option 3. Here our aim is to find f of x, which is given in terms of the sentences evaluation of cube root of 3. So that is given by x is equal to cube root of 2. So that is x cube minus 2 is equal to 0. So therefore f of x is equal to x cube minus 2 is equal to 0. F of x is equal to x cube minus 2. Just differentiate that and substitute them in the general form of Newton-Raphson method, that is given by xn minus f of x divided by f dash of xn. So just simplify the things. This will be 2x cube plus 2 divided by 3xn square. Just take 2 by 3 common. That will be xn plus 2 1 by xn square. So this is about KSET. This is about GFGC 2015. One more question. This is a question of December 15 CSR net from part B. This is a CSR net question which says, let f of x is equal to ax plus 100 for a belongs to R. Then the iteration scheme, that is given by xn plus 1 is equal to f of xn for n greater than equal to 0 and x naught is equal to 0 converges for. So here the scheme looks like the scheme for fixed point iteration method, fixed point iteration scheme. And it looks like, so x is equal to g of x. Therefore g of x is equal to ax plus 100. So this will converge only when modulus of g dash of x is less than 1. Now g dash will be a. So this will converge only when modulus of a is less than 1. So we have to just substitute the values for that, such that modulus of a should be less than 1. Here for a is equal to 5, 5 is not less than 1, 1 is also not less than 1, and 0.1, point is obviously less than 1. Therefore the option 3 is correct option. So therefore for the convergence of the iteration scheme, the value of a will be 0.1. This is about CSR question. Now one more question from December 2015, which is from part C, which says the iteration scheme xn plus 1 is equal to 1 by 2 into bracket xn plus 2 by xn for n is greater than equal to 0 for a given x naught not equal to 0 is an instance of. So that means this iteration scheme is obtained by which function? So the options are fixed point iteration for f of x is equal to x square minus 2, Newton's method for f of x is equal to x square minus 2, fixed point iteration for x square plus 2 by 2x, Newton method for f of x is equal to x square plus 2. So just see, we have some different functions. Here first we take first one, fixed point iteration for f of x is equal to x square minus 2. So that will be for fixed point iteration x is equal to g of x. So this looks like x is equal to x square minus 2. For iteration it is xn is equal to xn square minus 2. It doesn't look like the given scheme. Therefore option n is not true. Second one is Newton method for f of x is equal to x square minus 2. Just use the formula. F dash will be 2x. Now from the Newton scheme, xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So this will be equal to xn. F of xn is xn square minus 2. This is 2xn. This will be equal to xn square plus 2 divided by 2xn. Just take 1 by 2 out. This will be xn plus 2 by xn. So it looks like the given scheme. Therefore option 2 is the correct option. Since it is from part C, so multiple options may be correct. Therefore we have to check for third and fourth option also. So here it is a scheme for fixed point iteration scheme for f of x is equal to x square plus 2 by 2x. So third option says fixed point iteration for f of x is equal to x square plus 2 divided by 2x. So fixed point iteration means x is equal to g of x. So thus looks as x is equal to x square plus 2 by 2x. So scheme is xn plus 1 is equal to g of xn. So thus gives xn plus 1 is equal to xn square plus 2 divided by 2xn. So taking 1 by 2 common, 1 by 2 xn plus 2 by xn. This also looks like the given scheme. You can observe with the given scheme, it is 1 by 2 into bracket xn plus 2 by xn. So therefore the option 3 is also correct. And the fourth option says this is Newton's method for x square plus 2. We can take Newton's method for f of x is equal to x square plus 2. Here f dash will be 2x. Just use the scheme. Xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So this will give xn minus, so that is xn square plus 2 divided by 2xn. This is xn square minus 2 divided by 2xn. So take 1 by 2 common, this will be xn minus 2 by xn. So here we have negative for that and the given as positive. Therefore the Newton method for f of x to x square plus 2 is not the option. Therefore the correct options are options 2 and 3. And this is how we can solve this question. Now we have question which I think it is a question of gate, which says let f of x is equal to x square minus 5 for x belongs to R. Let x naught is equal to 1. If xn denotes the sequence of iterates defined by Newton-Raphson method to approximate the solution of f of x is equal to 0, then what will be xn? Here they are using the Newton-Raphson method and function is x square minus 5 and the initial approximation is x naught is 1. Then they asked what is x1. So the general scheme for Newton-Raphson method is given by xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So for n is equal to 0, to get first approximation, x1 is equal to x naught minus f of x naught divided by f dash of x naught. Now f of x naught means f of 0 is equal to minus 5 and f dash of 0 is equal to, so here it is f dash of x is equal to 2x. So f dash of 0 will be sorry, it is x0 is 1. Here f of 1 is, f of 1 will be, x0 is 1. So f of 1 will be 1 minus 5. This is minus 4. And f dash of 1 will be 2 into 1. That is 2. This is equal to x0 is 1 minus f of x0 is f of 1 by f dash of, it is given 1 minus 4 divided by 2. This will be 1 plus 4 by 2. So that is equal to 3. Therefore, x1 is equal to 3. The first approximation by Newton-Raphson method for the function f of x is equal to x square minus 5 is 3. Therefore, option 4 is correct. One more question from GATE, which is from GATE 2011. While solving the equation x square minus 3x plus 1 is equal to 0 using Newton-Raphson method with the initial case of a root as 1, the value of the root after one iteration is 0 also. F of x is given, is x square minus 3x plus 1, and the Newton-Raphson method is used. Initial case x0 is 1 and first iteration is x1 is equal to what? Now the general scheme for Newton-Raphson method is given by xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So for first iteration n is equal to 0, x1 is equal to x0 minus f of x0 divided by f dash of x0. Here x0 is 1, f of x0 is f of 1 divided by f dash of 1. So this will give 1 minus f of 1 is 1 minus 3 plus 1. F dash of 1 is, f dash will be 2x minus 3. So f dash of 1 will be 2 minus 3. So this is equal to 1 minus 1 divided by minus 1. This is 1 plus 1. This is equal to, no, this is 1 minus 1. Sorry. This is 1 minus 1. So it will be equal to 0. Therefore, x1 is equal to 0. Therefore, the first iteration, after the first iteration, the value of the root using the Newton-Raphson method for the function f of x is equal to x square minus 3x plus 1 is equal to 0 is x1 is equal to 0. Therefore, option 4 is correct. Now, question of GATE 2018. Let f from R to R be a twice continuously differentiable function. Then the order of convergence of the secant method for finding the root of the equation f of x is equal to 0 is. Here they are saying order of convergence for secant method. We know that the order of convergence for secant method is the positive root of x square minus 1 minus 1 is equal to 0. That positive root is given by 1 plus root 5 by 2. Therefore, order of convergence for secant method is 1 plus root 5 by 2. It is in option 1. Correct option is option 1. Now, a question of MSET. It says, it is a question of MSET 2019. The question says, the first approximation of the root lying between 0 and 1 of the equation x cube plus 3x minus 1 is equal to 0 by Newton-Raphson method with initial approximation x0 is equal to 0 is. What is the first approximation? And initial approximation is 0 and f of x is equal to x cube plus 3x minus 1. Therefore, f dash x is equal to 3x square plus 3. Now, Newton-Raphson method is applied. Xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So, x0 is 0, 0 minus f of 0 by f dash of 0. F of 0 will be minus 1, f dash of 0 will be 3. Is equal to 0 minus 1 by 3. This is equal to 1 by 3. Therefore, x1 is equal to 1 by 3, which is in option 2. Therefore, the option 2 is correct. Again, a question of KSET 2023, which is from paper 2. The sufficient conditions for the convergence of fixed point iteration method to find a root R of the x is equal to g of x are continuity of g of x and g dash of x, continuity of g dash of x and modulus of g dash of x less than 1, continuity of g of x, g dash of x and mod of g dash of x is less than 1, and differentiability of g dash of x and g dash of modulus of g dash is less than 1. We have to remember the sufficient conditions for the convergence of fixed point method is that here continuity of g dash is needed and also modulus of g dash x is less than 1. So this is a sufficient condition for convergence of fixed point iteration method. Therefore, it is observed in option 3. Therefore, the correct option is option 3. Again, a question of KSET 2023, which has been asked in physical sciences. The question says, the first approximation x1 up to 2 decimal places for the cube root of 13 using Newton-Raphson method with the initial case of x0 is equal to 1.5 will be. Here, x1 is asked and cube root of 13. Cube root of 13 means x is equal to cube root of 13 and Newton-Raphson method is applied. x0 is 1.5. So x is equal to cube root of 13 will give x cube is equal to 13. X cube minus 13 is equal to 0, which looks like f of x is equal to 0. Therefore f of x will be 3x square, sorry, f of x is equal to x cube minus 13, which is cube root of 13. Then f dash of x is equal to 3x square. Now x naught is 1.5, that is 3 by 2. Now the iteration scheme is given by xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So because of Newton-Raphson method, it is NR method. Now for n is equal to 0, x1 is equal to x naught minus f of x naught divided by f dash of x naught. So x naught will be, here we have x naught as 3 by 2, this is 3 by 2, f of 3 by 2, f dash of 3 by 2. So this is 3 by 2 minus f of 3 by 2 is minus 27 by 8, and f dash of 3 by 2, 27. This is minus 27 by 8, this is 27. This is 3 by 2 plus 1 by 8. This is equal to 8, 12 plus 1, this is 13 by 8. 13 by 8 will be, 13 by 8 will be, I think somewhere I have missed, x cube root of 13, x cube minus 13 is equal to 0, f of x is equal to 0. This is x cube minus 13, it is 3x square. F of 3 by 2, 1.5 is 3 by 2. 3 by 2 means 27 by 8 minus 13. So this is 13 into 8. 104 minus 27. This is 77 by 8. Sorry. This is 77 minus 77 by 8. This is 104 minus 77 by 8, and this is 27. Here we have to rewrite, sorry. Just substitute that. F of 3 by 2 is minus 77 by 8. This f dash of 3 by 2 is 27. This is equal to 3 by 2 plus 77 by 8 into 27. This is 77 by 8 divided by 27. This is 3 by 2 is 1.5 plus 0.35648. 77 by 8, what is that? 77 by 8 will be 9 point divided by 27. X naught is 1.5. 1.5 means 3 by 2. F of 3 by 2 will be, 3 by 2 means 3 into 3 into 3, 27 by 8. 27 by 8 minus 13. 27 by 8 minus 13 will be 27 by 8, 13 into 8 minus 27 will be minus 77 by 8. This is minus 77 by 8. This is 3 into, sorry, here f dash value is wrong. F dash of 3 by 2 is equal to 3 into x square means 3 by 2 whole square. This is 27 by 4, sorry, this is 27 by 4. 27 by 4, and 4 1 is 4 2 7. So this is nothing but 1.5 plus 77 by 54. 77 by 54 will be 1.5 plus 1.4259 is equal to 2.9259 something. It's 2.92. 2.925 means 2.93. So this is approximately equal to 2.93. Therefore x1 will be 2.93. And the correct option is option 1. So that is 2.93. This is about KSET 2023, which has been asked in physics.